Hello and welcome to class today. Today we are all going to talk all about chemical bonds. Chemical bonds form when the total amount of energy from bonded atoms are lower than the total amount of energy from separate atoms. So there are two specific types of bonding we are going to talk about today. The first is ionic bonding. So ionic bonding is when atoms give up their electrons. There is a mutual attraction of positive and negative charges. So over there you'll see there's a lithium and a fluoride. The lithium has a +1 charge, which you would find on the periodic table. We will learn about periodic trends after this lecture today. Fluorine has a -1. So in an effort to be neutral, because 1 plus -1 equals 0, lithium and fluorine will bond together. The next thing to think about is that atoms are attracted through Coulombic attraction. This is again to talk about they want to be neutral. They want to come together and balance out those charges. And then finally, ionic compounds create salts. Now, not all the salts that these create are salts that you can eat. Things like NaCl are things like table salt. But other forms of salt can be dangerous, and we suggest that you do not eat them. So going into more of the salt category, salts is the only thing, for the most part, ionic bonds make. You take something called a metal and a non-metal and you add them together. We will again talk more about periodic trends later, but things on the left-hand side of the periodic table are metals, and the stuff on the right-hand side are non-metals, and these create salts. Salts are extremely hard. These oppositely charged electrons are some of the strongest bonds you will see in chemistry. Therefore, trying to melt them, trying to dissolve them, trying to manipulate them in any way can be kind of difficult. They have a really high melting point, so if you wanted to melt these things, you're talking about an extreme amount of energy that's required to melt them. But they are easy to break because they are brittle. Next, we have covalent bonds. Now, these are the type of bonds we're going to be focusing on mostly today. These atoms share electrons. They are typically the ones that Lewis dot structures are made of. Sometimes there's a few exceptions. You can make Lewis dot structures with ionic bonds, but they are not necessarily as complex, and they're easier to represent by just writing a chemical formula. So these guys share electrons. We'll get into something called electronegativity when we talk about periodic trends, but some atoms pull electrons closer to themselves than other electrons do, causing covalent bonding. They share, they don't transfer. Ionic bonds transfer one thing to another, but covalent bonds they just share the charge between the two. This brings us to Lewis dot structures. Lewis dot structures are basically the way that we show that this bonding is happening. It's a structural representation of a molecule where dots are shown of where the electrons. This is no way to say that that's exactly where the electrons are. Finding exactly where an electron is a very hard and extremely complicated process. This is just to help us visually see, okay, we know that there's 1 or 2 or 3 valence electrons, but we don't necessarily know where they are. We're just putting this into a concept so that way we can see and try to figure out how these things bond. The purpose of drawing the structure is to identify some lone pairs, and identifying lone pairs shows us where chemistry happens. And so we'll get more into this when we get a little bit later, but lone pairs show us where chemistry happens. And so how do we make a Lewis dot structure? The first step is we're going to count the amount of valence electrons for each atom. I'll get into the example a little bit later, but first step is you're going to count the amount of valence electrons. Secondly, the thing to think about is that shared electrons make a single bond, and 4 shared electrons make a double bond. This will be very important later when we're trying to count the amount of electrons that we have. Finally, each atom needs a full octet, so it needs 8 electrons around it in order for it to be happy. So we're going to use C and F, carbon and fluoride, to create CF4. Carbon, if you look at the periodic table, has 4 valence electrons because it's in the group 4. Fluorine has 7, and so that gives us 7 electrons around the outside. Now, this is a covalent bond because these are both non-metal items. Carbon is a nonmetal, fluorine is a nonmetal, so therefore we have to have a covalent bond. That means the electrons will be shared between the two. So, as we will see, carbon will give 1 electron to fluorine, and then we're left with carbon with 3 unpaired electrons. Now, what did we say? We said that all electrons want 8 valence electrons. And so in order for that to happen, they must bond together with 3 other fluorines in order to make carbon have an octet and each of the fluorines to have an octet. So after we are done creating our Lewis dot structure, we need to count the amount of valence electrons. Make sure each fluorine has 8 valence electrons and make sure each chlorine has 8 valence electrons. Then we need to count the amount on the periodic table. So we have 4 fluorines from the 7th period, so 7 times 4, and then carbon that has 4 valence electrons, but we only have 1 carbon, so 1 times 4. Now, does that equal the amount of total electrons that we see in our molecule? And the answer to that is yes. So we have successfully created a Lewis dot structure. Thank you for coming today, and I hope this helps.